My name is Mihriban Mıstaçoğlu. The first question is, which are the most picked and most banned champions? First, we can see the data we need to our project. These are the champion information. I changed the champion IDs in our data with the names of the champions in order to see the information more properly. We can see that the most chosen champion is Thresh. In other graphic, we also saw that the most banned champions is Yasuo. So when we choose these two champions, what is our probability of winning? Thresh can win at 47%, while Yasuo can win at 49%. In our second question, we had to find out what the win rates of the champions were. I changed the champion IDs in our data with the names of the champions again. We were able to see the champions with the highest win rate in the top 10. If we put this on a chart, we can see that Invern is in the first place by a wide margin. If we select the Invern on the main data, we can see almost all its possibilities there. Invern will help us win 55% of the game.
My name is Ertuğrul Özdemir. Start with the third question. Looking at the graphic, we saw the fly smaller spell was selected with very high rates, like this. And then we graph the winning the team bases on the selection. We saw the rotates are very close to each other. However, we saw the teams that closed the flush less had a slight advantage, 50.4%. This means flush selections does not have a direct effect on the outcome of the game. One of the reasons for this that there is no elements that will make a difference between two teams because the flush is chosen so much. Okay. Second. Continue with the sixth question. As an example for this analysis, we compared the team result with the first tower with the team that won. Based on this process, we subtract the count of how many of this first stage all winning the teams took. We visualize this data like this, and when the analyzer made due structure for the game, the most significant value was the first dragon. If team sets its strategy to take the dragon, gain the huge advantage over the opposing team. Another strategy approach could be baron because majority of the winning teams won the game by taking a baron. As a result of analysis, teams should have a special strategy to get the dragon and baron, because with these two objects, it has a great advantage over the opposing team.
My name is Talha Özsoy. Let's look at question 4. And probabilities of objectives according to winners, we can see that in this table. We can say that when the team wins, they got generally first blood, first tower, first inhibitor, and first dragon. Average number of objectives according to winners. The biggest difference between winner and loser are tower and inhibitor kill numbers. When winner is first team, tower kills, inhibitor kills, and second team's results. Let's look at question 7. We see that experience differences. The values is equal, but the sign is positive or negative. Also, the same thing is on gold difference results. When blue wins, average total minion results in this pie. We see that minions are not important more. In this sub plot, blue deaths and blue kills when blue team wins. Average kill results when blue team wins. We see that kills are more important than minions. This is a correlation heat map. After we using logistic regression algorithm in our dataset, first 10-minute dataset, these are our results, and we can see that our macro recall score is that on the training data on our test data received a macro recall score is this point, meaning that of the true wins and losses, our logistic regression model is predicting a percentage of this score of them correctly. We also do not have an issue of under or overfitting. Logistic regression feature coefficients versus win odds. These are elements of game. According to our bar plot based on the logistic regression model, we see that champion kills and deaths within the first 10 minutes of the match have by far the most impact on the outcome of a match. We can see that total lane minions and total jungle creeps and dragons are also of high importance. Surprisingly, heralds, vision wars and towers are of least importance.
Hello, my name is Fatih Özkoç. I will talk about one problem. According to analyzing dataset, can we calculate which team win or lose? Let's start. First of all, I import the dataset, which name League of Legends CSV. Then the next stage is manipulating of dataset. I captured only the information that interests us from the data list. These are informations that directly affects the result of the game. And the next stage is exploring of the dataset. A good indicator of how well your team is doing in a match is how many objectives your team has taken. These objectives are gold, player kills, tower kills, inhibitor kills, dragon kills, baron kills, herald kills. I will use these as source of the data when predicting the result of each match. Then next stage is splitting of our data. I want to split our data into a set that we train the model on and a set we test the model with. Using scikit-learn, I can split our data so that we train the majority and test the rest. The next stage is create and train model. With our split data, I can create logistic regression model and fit it to our training data. Now that we have a model, we can see how well we predicted the outcomes of the match.